Space is hard. It really is. We require planning and perfect execution to implement any mission. Like space travel, human bodies resist any changes. Hence, we have to develop that kind of mindset before proceeding further. For decades, scientists have been looking for ways to live on the Moon, travel in space, walk on Mars, and be multiplanetary citizens. The best example is the Apollo 11 mission of 1969, where humans touched down on any foreign soil for the very first time in its history. The journey was not an easy one. Astronauts had to undergo some serious training of that stuff. But the main question remains, why can't our bodies survive in outer space? Let me explain to you further. Stay with me. First place, when the Apollo 11 astronauts returned back to the Earth, a study was conducted on their bodies wherein some significant changes were observed. They had to undergo 21 days quarantine period, as they might have been exposed to not only radiation, but some harmful bacteria, which could have impacted others. Researchers are also of the view that venturing beyond Earth's protective magnetic field could cause long-lasting impacts on their cardiovascular system because of deep space exposure to radiation. Secondly, to check the influence of microgravity on the human body, NASA conducted a mission wherein twin astronauts Scott and Mark Kelly were selected. The plan was to send Scott to the ISS while Mark was kept under observation. It was conducted from the 27th of March 2015 to the 1st of March 2016 to conduct further studies. NASA astronaut Scott Kelly spent almost a year on the International Space Station, while his twin brother remained on the planet Earth as a ground control object. The idea was to test the famous study published in the journal Science that found that Scott's DNA structure changed because of radiation. From that study, NASA found that there was a slight difference between their genetic material. And it was expected. If we talk about the Mars mission, humans will encounter 3 different gravitational fields: zero-G environment, Mars gravity, and Earth's gravitational effect after returning. It is not as easy as people think, or it has been shown in sci-fi movies. It affects your every little function: spatial orientation, eye-hand coordination, body balance, locomotion, and motion sickness. Gravity is the need for the proper functioning of the human body. From blood circulation to bone strength, gravity controls every life process in our bodies. Space radiation is also an important factor that has to be taken into consideration. Earth's magnetic field shield has been protecting us from radiation for ages. But when we are exposed to the space environment, no such field would protect us. Earth's magnetic field, solar energetic particles, and galactic cosmic rays are 3 major sources of space radiation. Exposure to space radiation will increase the risk of cancers, heart diseases, and cataracts. Health risks from radiation exposure in space will lead to long-term impacts on the body. If you enjoyed the content, then like the video, subscribe to ScienceCept, and share this video. And don't forget to follow us on social media handles.